Alright, so I wanted to demonstrate the multiplication lattice method um, for today. So let's say we have two numbers like 25 times 346. What I've noticed is that it's better to put the larger number on top. So you put a 3, a 4, and a 6, and essentially they each get their own column. And then we're going to have on the side 25, which will go right there, and they will create rows. So I'm just go ahead and making that. And something to notice is that each place value gets their own column or row. So here's the hundreds, the tens, and the ones. And here, of course, there's only the tens and ones. And then you also add a diagonal that, yes, it does go through every box, but the way you want to do it is you want to start at the highest point. So in this case, it's right there, and then go all the way down to the lowest point possible while going through the middle. And my drawing is obviously not proportional, so it looks a little wonky, but that's how it is. And then you start at the next top point, and we would connect right here. And then you're basically going to multiply every point or every number by each other, with the bottom triangle representing the lower place value of the product, and the higher triangle representing any value that needs to be carried over. So as we go through this one, you can see that 2 times 6 is 12, and we're in base 10. So 2 would stay here, and 10 would go here. Or sorry, not 10, 1, because this next one is the next place value over, so it's just 1. And then 5 times 6 is 30, so the 1's place value is 0. And then the 3 would go here. 2 times 4 is 8, so it's 8 and 0. 2 times 3 is 6. Sorry, I just forgot to draw a line there. So it's 6 and 0. And then continuing down, 5 times 4 is 20, so 0 and 2. And 5 times 3 is 15, so it's 5 and 1. So now in this non-standard, we're going to add in diagonals like so. And whenever we add so much that it goes to the next place value, you need to carry that one over into the next set of diagonal, which we'll see in a bit. So now we're just going to write down our sums like this. The first one is just 0, and then it's 2 plus 3 plus 0, which is 5. Here it's 1 plus 8 plus 2 plus 5, so that's 7 plus 9 is 16. So this is where I mentioned it. So really, it's not 16, but it's just place value you don't really think about when doing this standard algorithm in the summation. So it's 16, you bring the 6 down here, move the 1 over, and here it's 1 plus 6 plus 1, which is 2. So now that I've finished all the place values with columns, you move on to the rows. So here it'll be a 7, sorry, an 8, and here a 0. So the one on the left is always your highest place value, and I got 8,650 in base 10. And just to confirm that's right, we're going to do 346 times 25 in the standard algorithm. So you get 8650, which is the same. And yes, so essentially going over it, you write your two numbers. I like writing the top one, or the larger one on top to create more columns. And then you add in these diagonals like I've drawn with the green. And that's pretty much it.